The Arduino-controlled three-phase interleaved boost converter with phase shedding is a PV to battery charger for a 48-volt system. In order to operate the device safely, basic knowledge and understanding of how the prototype works, programming, and electrical safety are paramount. The PV charger applies the concept of a boost converter. Its main feature is the implementation of three interleaved power stage components and the application of phase shedding. By the interleaving of multiple phases, the converter achieves higher power density, better thermal management, and improved reliability. On the other hand, phase shedding is a technique used in multi-phase power converters to improve efficiency, particularly at low power loads. To ensure safe operation, here are some tips to follow. To have basic knowledge of solar and electrical installations. Carefully read the technical user manual. Place the device in a place with good ventilation. Check and tighten connections. Now, how does the PV charger work? Let us first have a look at the parts and labels that can be seen on the device. For the operation, here are the following basic requirements: a PV module, a 48-volt battery, a computer with installed Arduino IDE software. Moving to the operation of the device, the key operation of the device is as follows: the phase shedding switches and the Arduino port. The operating procedure is divided into three stages, which are system startup, duty cycle or output adjustment, and system shutdown. For this demonstration, we will use a DC power supply which acts as the PV module and resistors which act as the battery or load. For the system startup, connect the battery first using the battery clips. Red for the positive terminal and black for the negative terminal. Then connect the PV module using the MC4 connectors. The phase shedding switches can be used to increase the number of active phases when the output voltage is unstable below the required output voltage, or when the output voltage starts to drop. It can also be used in reducing the number of active phases to improve efficiency with lighter loads. To adjust the output voltage at a specific active phase and loading condition, we need to adjust the duty cycle. Using a Type-C cable, plug the device through the Arduino port into the computer. Open the Arduino IDE software, then copy the code via the link provided in the technical user manual. Find the int index in the loop routine option 1. Select the desired duty cycle from the provided table. Take note of the index value, then copy and replace the value in the int index. Once the value is changed, compile and then upload the code. You have now changed the duty cycle and have adjusted the output voltage. For the system shutdown, turn off all active phases in decreasing numerical order until phase 1 is left turned on. Disconnect the PV module and lastly, disconnect the battery. That is all for the operation of the device. You may read the technical user manual for detailed information about the safety, parts, operation, and specifications of the prototype.